Good evening. My name is Paulo, and I will present our work called Analysis of Between Session and Within Session Calibration of a Motor Imagery Brain-Computer Interface System. I'll present the introduction, materials and methods, results, and finally the conclusion. Cross-session calibration is a challenge because of non-stationarity of the EEG and electrode setup differences between sessions. Accuracy agreements between within-session and between-session calibration is wanted for better estimation on whether the BCI system will need future recalibrations. In this work, we will analyze how the BCI accuracy in a motor imagery task is affected by cross-session calibration. We use two datasets, the BCI competition force dataset 2A and the OpenBMI dataset. Each one contains two sessions of data collection. We used two-class motor imagery for our experiments. In both datasets, data was bandpass filtered and sources were extracted using different ICA algorithms. Power spectral densities were extracted to be used as feature vectors. Features were selected using the forward wrapper strategy and scaled to have a mean 0 and standard deviation 1. To classify the feature vector between left or right hand imagery, we used linear discriminant analysis. Figure 1 shows the average BCI accuracy for each ICA method we used. For each ICA, its within-session accuracy is plotted in the x-axis, while the between-session accuracy is shown in the y-axis. We can see that the accuracies mostly float around the identity line for the BCI competition dataset. For the OpenBMI dataset, where we have 6 times more participants, the accuracies mostly lay below the identity line, showing a higher within-session accuracy. On average, accuracies were 0.3% and 2% higher in the within-session setup for the BCI and the OpenBMI dataset, respectively. Fast ICA and Extended Infomax had the highest accuracy in the within-session calibration, but had the highest performance drop for the between-session case. Different results in each dataset may be due to different participants' number. The research on robust processing and classification methods for between-session and cross-subject BCI systems is important for more general applications and for learning the similarities and differences in the brain behaviors between subjects. Thank you.